All right, I wanted to do some more examples of some of the harder area problems. I found this one from the textbook. It's kind of a doozy, so let's see if we can knock it out. So we've got a seven-sided shape. So I'm not going to draw this very well, but I'll do my best. And so we have M, N, that's the order? Okay. M, N, S, R, Q, P, O. Okay, so that's the shape on the outside. And then they also have the letter T in the middle. And what they're saying is that it's a circle that goes through radius T and it touches all those points. So there's a heptagon, that's our fancy word here, for a seven-sided shape like this. And then there's a circle that just circumscribes it like this. Okay, so if you squint at it, it kind of makes sense. And so the T is in the middle of the circle. And what they're asking us is they want to know something about the area of this triangle right here. And they're actually asking about the area of everything else in the heptagon. All right, this is super weird. All right. So we actually want to find the area of this piece, and this piece. That's what we care about. They told us one more piece of information. They told us that if I go from T to the end of anything, it's 25. So I can extend T out to any of the sides, any of the vertices of the heptagon. It's going to be 25, 25, 25, because it's a circle like that. Okay, so first thing that I know is that if I take 360 degrees and if I divide that by 7, that's going to tell me how many degrees are between each of the uh, outside points on the heptagon. So I can take 360 divided by 7, and it doesn't come out to be a nice number. I get 51.43 degrees. So if I go here and draw those little triangles, I'll have 7 triangles, and each of those 7 triangles has 51.43 degrees on it. So what I can do then is find the area of the entire heptagon by finding the area of one of its triangles and then multiplying by 7. So let's do that. Similar strategy to what I've done in the other videos. I'm going to focus on just one of those triangles. So it looks like this. I've got 25, 25, and then this angle right here is 51.43. So the area of a single triangle, using our formula, 1/2 times A times B times the sine of 51.43. Let's see what that comes out to be. So I do the sine of that times 25 times 25 times 1/2. Get that the area of a single one of those triangles is 244.32. But there's not just one of those triangles, there's actually 7 of them. So the area of the heptagon is 7 multiplied by 244.32. So that comes out to be 1710.26. Okay, great. Then what I actually care about is this area here, and here. And so what I want to do is subtract these other pieces here. So I'm going to use a different color to show you what I want to subtract. I want to subtract this entire black triangle right here. But the tricky thing is I don't really know the side lengths. I don't really know that side length. I could figure it out, but I don't know it. But I do know this is 25. I know that this is 25. And I know that this is 25. And so that makes it into 3 triangles there. And this triangle right here covers 2 sections. This triangle here covers 2 sections. And then this triangle here covers the other 3 sections. So let's break it apart. The area of, I'm going to call it a 2 triangle because it's like this one goes through 2 of the different spokes. It goes M to N to S. So the area of the 2 triangle is going to be 1/2 times A times B times sine of, I got to double this, whatever 2 times 51.43 is. And the area of the 3 section triangle is going to be 1/2 times A, 25, times B, times the sine of 3 times 51.43. 3 times 51.43. So we're going to do some calculating here. All right, so 2 times 51.43 is 102. Take the sine of that, multiply by 1/2 times 25 times 25, and you get that the 2 section triangle is 304. Oops, almost wrote that right. Okay, so it's 304.66. Now let's look at the 3 section triangle. So I go 3 times 51.43, do the sine of that, times 25 times 25 times half, and I get 135.57. Now for the grand finale, I'm taking the area of the whole heptagon and I'm subtracting 2 of the 2 section triangles and 1 of the 3 section triangles. So the shaded area is going to be 1710.26 minus 2 copies of 304.66. So I'm just doing minus twice. I could have doubled it and subtracted it. And then minus 135.57. And I get area of 965.37. So it's a tricky one. A lot of different steps there. But really all I did was use the area formula, 1/2 AB sine of C. Just use that over and over again. So please comment or let me know if there's anything that was confusing. And thanks for watching.